So, hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 117, and in this video we continue exactly where we stopped in our last video, and that was the place where I try to explain what our reference value is behind the scene. Let's see fast this one. This is this and here. So here I have created this referenced value. We assigned it another variable which we need because our reference value means we need all time an existing L value, and in this case it's a variable. And then I showed you how we created this one in our last video, and we already discussed that this reference value is not creating a memory address. And we saw, and then I explained it how we solved this, because behind the scene the PC is only working with a memory address. He don't cares about these variable names and not these values. He cares all time about this memory address, because you can assign a value to it, a variable name to it, or something like that. So behind the scenes, the PC is working with memory address. We as a programmer, we work with variables, because we are creating variables, changing variables, sending variables, and so on. That's the main difference. And this question is now, wait a minute, what was it? Why we learn then the thing what the PC is doing? Because we are programmers, we don't need to know what the PC is doing, right? It's actually right, but we need this memory address, because in C++, compared to some other programming languages, there is a connection point where we need actually really this memory address. And that's why we are learning a little bit more about this memory address. But in my explanation, it's not accurate, not very correct, but it's still right. But to understand it deep and right with the right definitions, you need to read this in theory, which means online documentation with good C++ books and so on. The problem is, if you go for this online documentations in C++, they to explain and to make it correct, they dive really deep into material and can be a little bit difficult for starters, right? Because this is a starter course. We are not intermediate or professionals. For example, if you want to go to intermediate level or to the professional level, then you have to read this in theory anyway, because there is no way around. You need this knowledge, and I will show you a little bit later here in this video why you need this knowledge. Because as a starter, we need this knowledge here only for a special keyword we will discuss, and for this reference actually, also to understand it a little bit better. But there is a keyword which is also very important. Which is the pointer, which is very important, and the pointers are working more or less with exactly this memory addresses. That's why we need them, and that's why we need to understand them. But like I said, I will explain this here so that you can understand as a starter without deep knowledge in technical terms. And I hope you understand it, and let's continue. Now I made the pre-work and let's continue. So we created now this variable name. This is a reference here, the right side, reference variable name. And a reference variable name is not creating a memory address, I said, yes, but instead it is asking when it's first time created, and that's very important. When it's first time created, it is asking for an existing L value, and in this case I said an L value is something fixed address in the memory. And we created this my telephone number variable here, and this created actually a fixed memory address here, and it know exactly where it is. And just a recap, this number here, what you see here, 4232, because this one has right now no fixed memory address. We just use it anyhow. We don't know even how we use it, but this one has not a fixed memory address like this one. We create this one, this has one. And this number which we are using here, this is just used anyhow. Let's don't care how this is at this point, because this is again something technical. And this number is just called this R value. right? So just if you hear something like L values and R values, L values are something which has a fixed created memory address and the compiler knows it. And these numbers here, these are just randomly created with a not fixed value so it can't refer to this value later. That's not absolute correct, but think about this at this point. This is okay. Okay, with that said, at start, what we should know is this reference value is asking only at start for a fixed place. Why is that so? Only at start, because at start it's creating this arrow. This arrow is a connection, and this connection is exactly this ampersand. I refer to a fixed place in the memory address. And after I have this connection, this memory address, I can use this memory address like this variable here. This my telephone number is using this memory address and its value. This variable name here, my number reference here, is creating this variable name, and it's using also a connection to this variable memory address, and then it can use, like the other one here, it can use the variable, the value, and the memory address of this one. It can't use this variable name on top because it don't cares about the other variable name. It cares only about this memory address. That's very important. And the memory address, you can see it. We can assign to it a value. We can change it, like all that what we do with a normal variable. So that's very important to know. Why it's important to know that it's only at start? Because later, let's go one step further. I can, after I created this connection, that is this arrow here, after that I can use this variable name now, which I could not before, and assign it a value, because at start here, let me cut this out, we learned here, if I try at start to assign a value, no, that's not working. And the reason for that is it says I need a L value at start. L value means I need first an assigned address, memory address here. This is exactly that, this connection here, this arrow. After this one, it gets this memory address, which is refers, that's why it's called also reference, it refers to an existing place, right? And right now it refers to my variable place, I have created here. And now after I have this connection point, I created this connection point. Now I can do what the variable itself can do, because I'm using now this address. I can do, for example, change the value here. This one, after it's connected, I can change here the value. And important is now to see, and that's why I made this diagram more or less. If I change here this reference value, which is connected here, it is changing also this value of this variable name, because you see it has also this arrow. It is just connecting to this address here, right? This number here, my telephone number, it's also just a connection like this arrow here to this address. Both are using the same address here, which means if I change this later with this name here, the value here, for example, I changed it to 324, then because this one is connected also later here, the value for my telephone number is also the 324. And that was, yeah, that you have to understand, because they have only one place. Both have only one place now. If one is changing something, the value, the other has the same value. If you change the value, the other will have the same value. And that was the place where I said, I tried to explain you very randomly that when you create a reference, it is connected to another another variable. I make this example, for example, it is connected then to another place, to storage place, so they have all time the same values later. And here this makes a little bit more sense, I hope, because we go now a little bit one step further and understand this in what it means in functions, because that was most time used in functions. Do you remember this kind of function? We use it at least a little bit. And you see, this is just a normal void function, which means no return type. The function name is reference function, and I call this reference function because this parameters here, what you can see, is exactly a reference parameter. It's exactly the right side here, this here. It is a reference parameter, but it looks a little bit different. It has not this assignment operator and then asking here, because the function, it still asks for this connection here. It is still asking for this one, but not in this way. The difference here is here a function call, which is down here. Let me show you this one. I call now this function here. This one is the function call. And when I provide this one with this argument, which is my telephone number, and you see it is the same principle like this diagram. All time when you see a reference, because this is a reference value, it makes the same thing. At the first time, it is asking for a connection to an existing place. In this case, I give this argument my telephone number, which is this one. And here, it calls this one here, and it makes this connection to backwards connection. I called it there something like a backwards connection to this caller. And you can see what I mean now with this backwards connection. It's not really a backwards connection. It's just connecting the memory address. It gets the reference. It's just getting the caller's memory address. So here, my telephone number is pasted later here in. And this reference says, okay, I get the memory address, what was pasted here in. So it was pasted in this, my telephone number. Here's my telephone number. I get his memory address. And now we have the same values, which means we have a problem in functions, because I said when you change one of them, the other one is also changed. That's sometimes intended, because that's why it's important to understand this, that they have the same memory address. And when you change one, the other one will change too. That's very important in programming to understand this concept. It's very easy when you understand this diagram here, more or less, because you have just to think it has only one place, both has one place connected with this arrows, more or less. And then we can change backwards the input. What I try to explain you here, here's the call, we call the function. I call it with this variable name here, but this variable name here will be pasted here. And this one connected like here, make a connection to this one's memory address. And now after this one, I can use now this variable name, which is a reference variable name, which is this reference variable name here. And now I can assign it a new value. And this new value will change. I called it backwards. In real, it is just changing the normal connected memory address, but this memory address is also connected now with the other one, so it's just changing this value here. And this is the thing you have to understand in the programming, but normally you don't have to understand this one here backwards, but it is good when you understand this one here, because it will help you to understand many things. I mean, how this works, why this so, and so on. Still, we are interested only in this memory address. This was a little bit for that. And let's go one more step further, because I want to repeat here one more thing, which is in programming comes very often. You will see functions which has a reference, not so often in this form. Why not? Because many programmers, almost all, will try to put in front of this reference a const. This one you will see a lot in programming. And a lot. Almost all functions where it is possible to make a reference, they will put it. Not all time it's a good idea, but most time it is a good idea, and they will put this const in it. And I want to talk about this one with this diagram a little bit. But this const means just, we learned about it. It means just, please, I try to explain it so very general, not very deep. It says just, please change not the variable. Depends where the const is placed, right? We learned also the const rule, right? If it's placed at the start, read the value which comes later. For example, this would be even a const int, which means don't change here the value, which is this integer value, which is passed in the variable, right? And there are some other rules, but I hope you know this, but that's not very important here. Important is when you use a const, please don't change the value, right? In this case. And the question is now, what has this to do with our thing here? That would be go actually one step further, which is not really important right now, actually. What I mean with that is just fast, so that you get here a fast understanding. Let's make this one very fast. This reference here, connection, right? This connections from this variable to this memory address, this new created connection here, this arrow or this arrow, they have a so-called read-write access, right? So they can read, I can read with this, and I can write with this, and right. Which means read means I use this variable value. For example, I created this value here, and read means just I use it. What I mean with use it, let me show you this one too. Let's make this fast, not const. I'll just say this read write means use this value. For example, this is a use case here. I put this value out, stdc out, we know this, and here put this value out, and that was not the right use case. Sorry, here is the right use case. I put this my value in this function, right? It goes here in this new param, and now I can use it. That is the use case. So I can use it, and this one is not using it. This is even changed. It's also not the right, sorry. Use case is this one. Now I got a real use case. Use case is this one. Let's say I make here a new variable int assign a value, something. And now assign a value, this one here. I just read this one here, number param. So this is, for example, just read. You see, I'm just reading the value here from this storage. So this one connection has read and write, but write is something else. Write is this one here. I take the new param here and I write a new value to it. So which means in this case, to make it more easy, we can make so this read is red and blue is write, and we can say now write to it starts, this variable is going to write it. We make here a new connection. This is my write connection, and then we make here a read connection, which means it comes from here and it's going to read it here. But this blue red line is in this one connection here. This is just to understand we have here read and write access. Okay. And this read and write access will be destroyed by by const. When we write here const, it says now I break your write access. So the const here, when you see a const something here anywhere, let's write it here, and const, let's make const is green. If you read a const, it's like a blocker. It says here I block this, I cut this line here, right? You can't you can't write anymore. You still can read, but you can't write. So that's a little bit the const. I go not too deep into this one, and the reason why I talked at all about this one is what I'm going to explain now is the first step was they are using in programming, in C++ programming, all time this kind of form. You will see this all time. You have to understand this a little bit well. And const in, you see, they still give you an access point to this address, but not write point to address. And I explained you this in general a little bit different. I said you there, normally we could just use here a normal variable too, instead of this reference. Why they won't use here a reference? Let's get rid about this const for a moment and ask, hey, why the hell we make something so complicated like const and int and reference and then all this kind of stuff? It's too much complicated. We can make it very easy. We can just kick this reference as well and say, here, use this variable and put it in, and we have no problem. That works fine. It's easier to read. So our life is very easy. And why the hell are all programmers use, which is the same thing like const int reference? It's almost the same thing. Not technically, you see, it's not the same thing, right? Technically, we can see, no, behind the scene, it's not the same thing. Now we can see it, because when I explained you this one here, it's almost the same thing here. I told you, look, this one looks similar to its, so the same behavior like const and right, this reference here. That's similar, but behind the scene, no, they are absolutely not similar. And the big difference is this reference is not creating this memory address, and this memory address, like I said, is connected to this int here, in this case 4 bytes, which means when the programmers use in C++ all time this const int reference, they just skip creating this memory address, which means they are skipping this creating storage in space. They won't skip this storage place. Yes, the storage place in your memory. They don't want to create this. They don't want to waste this. And that's the only reason why they create this const int. And of course, this const is there so you cannot manipulate backwards. Like I said here, const says you can just read it, but not manipulate it. They want not that you manipulate it. So, first of all, let's recap this one. With this reference, they are just avoiding creating a new memory address. Because if you would have here not a reference in functions, you would create here a new memory address, like here, if it was without reference. So with this one, if I get rid of this reference and you pass here an argument, and this one is creating exactly the same like here, a new memory address. But the problem, but the good point is, you can not change it backwards, because this is normally good. A reference can change it backwards. That is bad. And that's why they add also this const, which means you should not change it backwards, and it must be a reference, because we don't want create a new memory address. And the last question is here before I stop. Wait a minute, why? Okay, I understand it. They don't want to create a new memory address because it has storage there, and they don't, the programmers are lazy, or let's say they don't want waste storage. That's the only reason why they use this const int, and this const means also they want not make possible to write in it. Okay, I hope till this point you understand it anyhow. The last question is, makes this sense? I mean, this is just 4 bytes here. And then you will read, when you read on forums or on books, C++ books, that makes sense for big classes. So what I mean with big class is the last thing what I show you here, because then you understand this one well. Let's say we have here, like I said, a big, let me Control Z this fast. Here. We have not talked about classes right now, but the class is the same type. Let's say we have a big type there, like int, but int is only 4 bytes. Minimum can be bigger, but you will see what I mean with this one. Type is just later a custom class. We have a variable name. Let's start again with a variable name. The variable name is called big. Variable. All right, we start with the variable name, which is called big variable. Actually, we start not with the big variable, but in this case, we know there is something called something like big variable, but the real thing is when we create a class, let's say here another int, it watched first this int and it will say, I create first a, like I said here, a memory address. I find for you a memory address, right? This is the first step normally. Here, I find for you. But this big variable is using another type, not int. It uses a very big type which contains not 4 byte like here. Let's make here 100. 100 and not bytes. We write here megabytes. This one got 100 megabytes. This got 4 bytes. This 100 megabytes. This is a big difference. And here again, it finds again anywhere this 100 megabytes in your storage. It will find this place. If it's possible, it will find it. And then it creates another address for it. So it knows here you can save what you want. And this one is 8, right? And this variable, big variable name, will be connected to this address because it finds first. It will first create this address here, then it connects all what you need. And here it will connect also your values. So let's say you have here, let's say you have a class, which means there can be different kind of values. We have not talked about classes, but let's say this got more values. Right, so it got here, for example, let's say value 132. Then we have here something like month, a word, and here we have even a picture, picture one, something like so, a picture from the web or your pictures which you made, something like that, and all these values, let's say. They are all this one you can connect here. It's similar to this one, right? The only real difference is here you have here more values, and this means you need more space, like 100 megabyte, which means this is much bigger than this one, much bigger. And this is the point where programmers says, wait a minute, no. We need definitely this not const. Where I said we start with this one, where I said, hey, this is the easiest solution. This one, right? We no reference, no cons, we skip all this one, just use the normal int. And when the programmers encounter something big like this one, they said, no, please not. Well, let's make here a circle 2 because this is now one place. And this is our second place. And then these programmers say, wait a minute, I'm not interested that behind the scene, the PC is creating again a new memory address, this one here, which is, it's a new address, and which is also 100 megabytes big. You know, you see, if this is so big, and you create just to, again, here, let me show you what this happens here. This one, let's say my telephone number is now 100 megabytes big. And if you use the normal way without a reference, this place here will create it like a normal variable, which means it's not a reference variable, it's a normal variable, and a normal variable means it creates all time a new fixed place. That's why it's also called a copy. It copies this value to this place, but in real it is behind the scene. It's creating for you a new space, a new variable space, which is 100 megabytes big. It has a new address name here. So let's write here. For this one, I give you an A123 F2, something like this one. And then it copies all the values from big value, which means to this one here. So it recreates all things here, more or less. You see, it will, because it copies now all these values from here, what it finds in this address to this place here. And that's why also copy all things here. But the only thing which is new is really this address here, probably. Name, address, memory, this address name here. And the variable name here. This is the only thing which is probably new. And in my case would be this number param here. Let's write here number param in. All right, this is new and this is new, and all other things, the values here are copied in it. And we have now a second storage place in our, a second storage place, right? Our second memory address means all time here, this 100 megabyte here and 100 megabyte here. And programmer says, wait a minute, no, please not. I have a problem because a PC has something called resources, and sometimes you can't do this. And if you do this, you're wasting performance, you're wasting storage, and that's not intended for a programmer. A programmer will have a very good performance, which means it should run fast and it should not waste storage like here. And the solution was this reference, what I did before. If you use a reference, let's change this to a reference first. We use a reference. So they changed this normal variable, which was a copy, to our reference, which means, let me write here with red, which means, oh, not red, let's make this with this color here, which means a reference means we don't need a copy of values. This one, the value copy, we don't need that. Haha. I don't need an memory address. Reference means I don't need a memory address because I will use an existing one. And that means the only thing what I really need is a connection, a reference connection. And I say, okay, I have my new reference name that I need, number param. This is this number param here. That is the only thing what I need. And then I reference to the right type, which means to the right, this memory address with the right storage here. That means I need here only a connection here. That's the only thing what I need. And then I have, and what I gained, what the programmers gain with that. They gain here this 100 megabyte. They don't create storage place. They say, yeah, less storage, and they say this one is faster because this is just a connection in the same place. So, and again, this is not absolute accurate. This is just to understanding for starters. If you need accurate understanding behind the scene, you have to dive in to documentations, read the real papers and how this works behind the scene. But we are interested just to understanding this memory address a little bit. And one more step was there, right? That was just why they need here a reference and why that was not the final form. The final form is you will see this one too, but most time const. And the const means here, let me show you this one too. They create here this connection, but they don't want that all these things here, what are most time they not want. I can't say they don't want. Most time they don't want that this new created variable should rewrite here some values. It should just, like I showed you here, it should just read these values. That's why they write this const, it's blocking it. If you write a const, which means don't change the values backwards, which means in this address here. But if you write no const, let's say, you say you can change this, perhaps you intend this. Sometimes they make a backwards assignment, which means they intend to change this backwards. It's a little bit strange, but sometimes that happens. And that means you can change here the values backwards. So, and I hope that makes a little bit more clear. If not, no worry. No worry. If you have understand nothing, perfect. It's also okay. Because what you should understand is we will talk about this variable address a little bit more because we want to use it. And if you understand it, it's very good, because there is one more comment which I want to show you. And that is that every variable, for example, this one has a memory address which we can print out. I showed you this one in the last one. This way here is the normal output, right? stdc out, and then I write that what I want print out. And what I want print out was my telephone number. And if I print this out, I will get now my telephone number. But careful, my telephone number is here on top, global variable 423. Then I call this function here. It is a int reference. It is not const, which means I change this one. So it will be not not this one, what it says here on top. We can see this. I start this fast. And you see it is 10. And why is this 10? Because this is a reference without const. And let me show you, this is exactly this one here on the bottom without const. It has the same address. It was changed later because at start I can't change it. Careful, remember this. At start you can't change it when you declare this variable with the start values, but later you can use this reference variable and change it if it's not const. And that happens exactly here. That's why we have our output. Our output was 10. So with that said, I'm almost finished. I think I want to show you. I want to show you that we can find this, and that's very important. That's why we made all this stuff here. We can find this memory address, right? I talked all the time. We are interested in this. Actually, not this 4 bytes here. We are interested in this memory address. All time about this one, because in C++ we will use it. There is a connection point between programming and background PC program. Let's call it, this is our programming place where we care about variables. This is the PC, how he cares about variables, which means he cares only about this memory addresses because he works with that. And now as a programmer, this is the point where we need this connection, because we can call this memory addresses. And how we can call this here, when we put, I showed you this I think already, if you put in front of an ampersand in front of this memory address, it says please tell me the memory address of this variable, not the value. Careful, not the value, the memory address. And when we start this one now, and then you see a very strange number here. Let's copy this one. And this is now the value of this here. And you can see this should be 8 long in this case, and it starts with 0, 0. And why this starts with 0, 0, that you can read online. This is just memory address and hexadecimal values, and so, but that's not important right now. We are interested only in this one. So, and why we are interested in this one, because soon we will talk about pointers, and pointers are using actually this value. So in programming, let me show you this one more time. In programming, normally we don't use memory addresses. For example, there are other programming languages, they don't care about memory addresses, but in C++, we will learn soon pointers, and they say, give me a memory address. And actually, this reference here, when you watch closely, is asking exactly the same here too. Here it says, give me, it says, okay, it says, give me an L value, but in real, an L value is a memory address. Give me an existing memory address which was declared before. So we are using actually this memory address at this point when we learned references, and that's why I dived a little bit into this memory addresses, and we will learn a little bit more about it when we come to pointers. So I talked a lot, and what I have to say, one more thing, or even two more things, you have to read this in books if you are interested to get better in C++, because if you go intermediate and if you go professional, then you need theory. Then this explanation, what I have done here, is too bad, because you need a little bit more accurate understanding. And this is the last point what I want to show you before I stop this videos and this explanation about this memory addresses, why we need to understand this. I mean, well, it's okay. We know you can even program in C++ without understanding anything about memory addresses. It's possible. I mean, you see these references need memory addresses, right? But we also use this till now, and that there was no problem, right? In my exercises, I had there's some functions, and we could use references, and we would not care about these memory addresses at all. But why is this then so important for intermediate and professionals to know about this kind of stuff and all this background knowledge? Why? I mean, you can make and learn C++ without it when you use some other rules, which comes basically the same thing. But let me show you one more thing, which you will encounter in future. And this is only one example, but there are many examples. And the problem was, there was something like recursion function, right? Perhaps you remember this version where I talk a lot of functions in many videos, and one video was talking about recursion function, which a recursion function is just a function who is calling itself, right? Something like that. So let's say this function will call, let's make about this function a recursion, or let's make a new function, recursion function. It's very fast. Let's make this recursion function, recursive function, and here I give it a variable int. I don't know what I give, int counter value, something like that. I don't know what I'm doing here, but I create just a function, a recursion function, and the counter value here, let's say we have to call a recursion function, means it calls itself again, right? So I have to call myself again, recursion function. Then I have to pass here a counter value, and this counter value, we can do something here fast. Let me do something here and make a Stack Overflow soon. Okay, let's write here. I write here int number start number. Let's make it faster. Start number is 0. That's all time good. And then I say, okay, I put the start number in. This one will call itself with the start number, and it will then set, this one will let's say this one will cause an error, Stack Overflow, because it's calling. This is called an infinite recursion. Don't make this, because when I start this one here, okay, here is this one missing. This will be called an infinite recursion. It would cause a crash, Stack Overflow or something. Don't make this. And even let's make here some breakpoints. Let's say if fast, and no, let's make a while. No, not if. Make a if. Let's say if start number is less. Let's make this recursion function limited, because like I said, if a recursion function goes over again, it will cause an infinitive loop, and infinitive loop will call creating too much storage space, which means it will make a stack overflow. But I don't go now too deep in this kind of stuff. It's interesting, but I show you only that what we need right now. So let's say start number is less than 100. It's okay. And then if this is the case, you can run this one. And I don't use the shortcut, of course. I could use there the shortcut as well. We as a starter, we don't use the shortcut without these braces. And the reason for that is, like, again, we want to see the scope. That's the only reason, to make it sure readable for us. And then we need only one thing here, which is just incremental, right? Because this number is not incrementing at all. Let's write here start number, not this one, start number, and we increment this one. So, and this one will now increment all time by 1. You see this? It's okay. And now, of course, we have to call this. And to see something out, let's do here perhaps. Let's do call our stdc out here. stdc out. All right. And then we increment this. We call this here. It's possible. And yeah, that's working. The only thing what I miss is the call, of course. Let's make a call here too. And we have here this one. Let's get rid of all the other things, because I don't need them right now. And I just call this function here. And interesting is I don't need here. Oh, I need. All right. Let's go here. And then here, param, let's say argument. First of all, I need to create a value here. Start number 2. Perhaps I should not make this one. I made here wrong. I should use here the counter value. And here the counter value output, and then here the counter value this one. I made this a little bit wrong. Let's make this one, change this fast. Yeah. We'll paste Control V, and let's increment this counter value, because I could make this other way too, but that's the reason why I made this. So all right, let's go here, and here the counter value. And here the counter value is outside int start value. Start value. I make it just outside and start here. And the start value I pass in as an argument. Value. All right. I think all that what I did so far is clear for you, because we have talked about all this kind of stuff in our videos. I just made a recursive function, and I hope it works. And there is something wrong. I don't know. There is something wrong. Let's see what's wrong. And when I start this one, we see nothing. That's bad, because I have already and what it says here, return a value. Okay, that was the problem. Let's make, of course, that was a int. I make not a int. Let's make a void no return value, because in our case I don't need a return value. And with that said, I need one more thing perhaps we can make, which is I have it, and that works. Okay, let's start it and see what happens. And you see, okay, a new line I could make, but it goes down and not straightforward. All right, let's make here a new line at this point perhaps. And start. And now we have all the numbers in new lines, and that is exactly what we know. This is very easy and simple. And the problem was in recursion function, right, where I said, hey, when you write a recursive function, careful, it make fast the storage full, right? The storage is actually something we discussed today. And memory address, when it's created, it finds a place where it has enough storage. For example, this int has 4 bytes, needs just 4 bytes, so it will find first in your RAM anywhere a storage where what has 4 bytes, and then it will assign an address to it, and then it knows it assign later then your number in it. It assigns your value in it. It saves actually in this 4 bytes. It's not really assigning here to it. This value here will be written in it in this place here actually, where it says 4 byte. But I made this just so as a demonstration. That's why I said this one is not accurate at all, but it makes simple. It's still okay. And yeah, let's continue. So what happens here is this recursion function can cause a stack overflow, I said, right? That was the thing, that was the problem. So we go here and let's create a stack overflow. And how we create a stack overflow here, I say if you make this value too big, it will create a stack overflow, which means now this value is really big. And when I start this one here, I don't know if it's creating already a stack overflow, but it can create a stack overflow and bang. And what you see now here is a catch. And let's read this error message here. It says here unhandled exception. It's not handled, okay, in this exe file, and it says stack overflow. This one is a very hard to catch error when it's really occurs in program. While you are programming, you can still test this and catch it. Later, if it occurs during a finished program, it's a little bit harder to catch it. And now, why I'm showing you this? Why I'm showing you this recursive function and this stack overflow? Let's go one step back to our diagram again. And I said, when you get intermediate or professional, then you will understand to use this knowledge here in theory to solve problems like this one here, what we have. So for what I mean with that is, for example, as a beginner, as a starter, you say, okay, it causes a stack overflow, then I have just to find here, for example, a lower number. Right, and then this is solved. So for example, like me, we can find here no lower number, and when I run this one, and now I have to take in account all time this lower number. This one is causing no stack overflow. It used and stops, and I have to take this in account. As a starter, that's okay. An intermediate and a professional says, hey, let's watch what happens behind the scene. And what they do is then, okay, they go here and they say, okay, behind the scene, this recursive function will create all time something like a storage place, right? And this is something to do with stack and heap. This kind of function will be created something in the stack and something in the heap. The stack has not so much the storage place, but this one I'm not going to talk here because this is another topic, a big topic. Like I said, when they are talking in C++ about storage, they will talk most time about stack and heap. Keep this in mind. They are not talking about, like I said, anything in RAM, for example, the read access memory. The reason for that is the heap and the stack are actually virtual memories which are created in the RAM, read access memory, for example. But when they are talk about storage, they talk only about stack and heap. So you have to read about stack and heap to understand this a little bit better. But let's continue with our exercise. So a beginner don't understand this one without background knowledge. But now we have a little bit background knowledge, like here. They say, okay, when I call a function, all time this, let me point this out with this orange here, this all time, for example, this 100 megabyte is created, right? Because this function here is creating the storage, and then it calls again, creating the storage, it calls again. Creating the storage, it calls again. And the storage, like I said, is perhaps limited, right? The stack where it's called, it has a limited size. And if you flow, it's called, you go over it. If you break this limit, it will cause a crash, and this is the Stack Overflow. You break this limit, my friend. You have not keep this in account. And now an intermediate or a professional programmer says, hey, I know this background knowledge. Then I can make a cheap optimization. And optimization means now in recursive function, the only thing what I have to do is that these values are not created all time again and again so that it becomes too big. And then you will see on the web optimization function for recursion function. It is called tail recursion optimization, which means it is still a recursion function like this one, and they will make it so that it's only creating this 100 megabytes 3 times. So 3 times it's creating, or 4 times, depends on the implementation. They are creating, there are some values in the stack, but after these values are created, they make another call, an intermediate call, so that it's not created again. That's a little bit hard to explain here. Let me go fast here to the web. I write here in what is called recursion function tail something like that. Say plus, I don't know. Let's go recursion function tail. Then we have your stack overflow. What they say. I need just optimization. No, they have not the optimization here. Tail recursion. I think this one is this tail recursion, something like that. Is this tail recursion here? Tail recursion. Yeah, too complicated again. Now let's write the tail recursion. Let me show you this one. That's interesting. Tail recursion, and then Wikipedia, perhaps wiki. Perhaps they have this one. Tail call, and let's see if they have this one here. Yeah, more or less they have it. So, example programs. Whatever, here, what they do is then, they are calling this function with tail style something. This is, and then where is this tail recursion? Anyway, that's a little bit, I think I need there find this one here to explain all the steps by this. I skipped this explanation what the tail recursion now is. In a sense, sorry for that, but I think I need a special video for this one. What they do is with this knowledge, they know, okay, we have just to call, change the function so that we don't call it on the, that the storage is not called again too much. And then they are just calling the recursion function. They change it so in a way that they create here an intermediate function, and then this function is calling then this recursion function again. And these values which created here are only created 3-4 times in the stack, which is then the place, and this will not cause a overflow. It's then similar to the example what I made several videos ago when we talked about function. It was with, it's similar to a while loop. A while loop is it's not creating all time new values. This one is only creating 4 new values all time, but it gets then rid of them, and that's causing not a problem. So the thing is, if you know more about the background, you can make optimizations, right? So if you get better and better, well, you are a starter now, but if you read more and more the backgrounds, you can react on these things and make your own optimizations. As a starter, for example, what I explained, you know, we need just to know this is a recursion function, and if it's greater than 1000, it will make a stack overflow. that's not work. So what we do is we just make a lower number and that's it. But an advanced user or professional say, hey, I can optimize this, or I have just analyzed it a little bit. Either I change this value anyhow dynamically, that's not possible, or it is possible but not recommended. The stack has all time these limitations, and the other version is I change it programmatically so that I can avoid this recreation of this storage place. So I stop here and say that was the real reason why you need in future learn also a little bit about the background to get better in programming, because intermediate one and a professional one, they need the ability to optimize, they need the ability to find bugs, and that's another topic. Bugs means if there happens an error, if you have background knowledge like this one, that this one is a memory place and what this memory place doing in the background, then you will understand all these errors which happens here in front or here below and what they are saying very easy. As a starter, you have probably a hard time to understand what the hell is all this chaining errors, what the hell are what is that? So sometimes you don't find, some are easy, some are very difficult, and if you get more and more background knowledge, it becomes easier and optimization becomes easier. You understand all things, you know why to use what and why not. For example, here in my example now, I hope you understand why many programmers use const int now. At least if you understand this from this video, that's very good, because then you understand one fundamental concept, which is just this thing here, to avoid just this big storage places. Yes, and with that said, I talked much. I will stop now here, and we are finished now with at least enough for us with this memory addresses. We are going a little bit further, which means we are going to pointers, and yeah, there we will use them definitely. And with that said, if you have any questions or any complaints, write it in the comments. And the last step is I would recommend that you read a little bit this in theory, especially memory address and stack and heap. Perhaps memory address, this one, because this one we will use, especially memory address with reference. And if you want go on a little bit reading pointers, you can start reading pointers, understanding pointers, because that's the next thing what I'm going to explain. And pointers need memory addresses. That's why I made this whole thing here. We have to understand this one here. That said, good luck and goodbye.